All right, folks, so welcome back, and we are now getting into the nitty-gritty things. So, in my opinion, you guys have already learned a big chunk of the material that you're going to need to know in order to be successful in this class. I'm not going to say it. I'm not going to say that quite just yet, though, because there are a few more important things that you're going to need to know. But essentially, those things are going to build off of the building blocks that we're learning now. And this is one of the final big pieces of this class. So we are now talking about accessing memory. And before I go into code and show you how you would do that, we're going to need to talk about some theory for a little bit. I said I wasn't going to do that, but I feel like when we get into this kind of thing, it's going to serve you guys really well to know exactly what's going on under the hood. Because in those higher level programming languages, such as Java and Python, the computer did a lot of that bookkeeping stuff for you. But guess what? You're in assembly. You're going to have to do that yourself. But it's not that bad, and I'm going to show you why. So, what does it mean exactly when you index an array? Well, think about it. What is an array? In a programming language, whenever you create an array, what's really happening is there's a chunk of memory that's allocated which holds a bunch of stuff. So if you have an array of integers, it's just a big chunk of memory addresses that hold a bunch of stuff, which in this case is integers. So let's suppose I have an array called A. It's just the integers from 1 to 6. And in the first case, I want to suppose that each element is only 1 byte long. And the first element, or the base of the array, is going to start at the address of 0x1000, as I have there. And what does A indexed at 0 mean? What does A indexed at 1 mean? So when I go down here, in general, when you index the nth element, that's the same thing as the element at your base address plus n times the size of your data. So in the case where we are 1 byte long, I'm going to scroll past this so you don't see it. So A of 1 in this case is going to be base plus 1 times 1, because that's the size of our data right there. It's 1 byte long. So our base is going to be 0x1000. So the actual address that the second element is going to be at, actually, I'm sorry, I said first, but it's really the second, is going to be 0x1001, because we jumped over 1 byte from the base address. All right, so with that being said, let's say that our data is a little bit bigger. Guess what? It's the same exact logic. So let's say that we are working with integers that are 4 bytes long. So if we have A at our third element, index 2, let's see, that's going to be the base address plus 2, but this time instead of being 1 byte long, we're 4 bytes long. So the address that element is going to be at exactly is 0x1008, right? The way that I like to think about data in bytes, I know when you start talking about bits and bytes, the terminology is extremely intimidating to some people. I know that when I took this class, it was somewhat intimidating to me, but I used to be a long jumper in high school, and some of you guys might have done that kind of stuff in once in your life too. And so basically, long jump, you just jump into a sand pit. You see how far you can go. Now, whenever I'm thinking of data sets and arrays in assembly, I think of each element as a sand pit. Let's say, and the number of bytes that each element is how long that sand pit is in feet. Now, they don't actually have an event where there's multiple sand pits lined up back to back to back. But if you imagine just laying out a bunch of, sand pits that are, I don't know, 4 feet long. That's a pretty small sand pit, by the way. And that 4 feet is the same as 4 bytes. So in order to jump from one sand pit to the next, you have to jump 4 feet to get to the next one. If you want to go 2 sand pits down, you got to jump 8 feet. So I think that's a good analogy to look at this. So again, that's just kind of some technical jargon that I threw at you about what it means to index an array. And to be successful in the problems that are to come, you have to know how big the data is that you're working with, because there's some problems, there actually is a problem, I'm pretty sure, where you're going to be getting the average of the number of elements in an array. And I don't remember how big they are, but they're not 1 byte long. They're more than 1 byte long, and you're actually going to have to go and look. So in the next video, I'm going to show you how to tackle a problem like that. So I hope this helped you guys out and prepared you guys further for the set of problems that are coming. And if you have any questions, feel free to comment or reach out to me during lab time.